In class 10, subject Maths First, lesson Quadratic Equation. We have to see now solution of quadratic equation by completing the square method. Lastly, we have to see solution of the quadratic equation by factorization method. But today we have to see the solution of quadratic equation by completing the square method. Completing the square method, in this method there are two types of quadratic equations. See here, these are the two quadratic equations. In these two equations, see carefully, square term coefficient will be here 1, but in this case there is 2, and middle term and constant term are there. First we have to convert the coefficient of square term is equal to 1. In the first equation, coefficient of square term is 1, therefore we can't convert that one. But in the second equation, coefficient of square term is 2 here, therefore we have to convert this equation into square term of the square term is 1. That's why we have to divide this equation by this coefficient by 2. It means 2m square upon 2 plus 9m upon 2 plus 10 upon 2 is equal to 0 upon 2. Means we have to divide 2 to the both side of that equation. Then that equation becomes 2 1s are 2 5s are. This equation becomes m square plus 9 upon 2m plus 5 is equal to 0. Then in this case, coefficient of the square term is 1. Means we have to convert that coefficient into 1. These two types of examples we have to see today. What is the complete square we have to see here? A square plus 2ab plus b square is the expansion of a plus b bracket square. If suppose they are given to us this case, left side of that equality, we have to take square root of this square term, that is a, square root of the second square term, that is b, and middle sign will be plus bracket square. Means we have to multiply this bracket 2 times. Finally we get a square plus 2ab plus b square. Middle term sign is at the middle of a and b here. Okay. Similarly, a square minus 2ab plus b square means its square root, that is a, square root of b square is b, and middle signs we have to take at the middle. Okay, means a minus b bracket square. This is the complete square. This is also complete square. Okay, today we have to see such type of examples in this case. Okay, see here, solution of quadratic equation by completing the square. Means we have to make here left side, that is the complete square. We have to see two types of examples in this case also. See here, x square minus 5x minus 3 is equal to 0. First we have to take minus 3 to the left side of that equality, then it becomes plus 3. See here, x square minus 5x plus 3 is equal to 0. In this case, coefficient of square term is 1. Therefore we can't divide 1 to the both side of that equality. Already 1 is there. Okay. In this case, see here, LHS is not a perfect square. We have to take square root of this one, that is x, square root of this one, that is root 3. But this is not a perfect square term. We have to add here perfect square number to the left side, and also we have to subtract that perfect square number. Which is that one? We have to observe first. Add a suitable term to the LHS, then it becomes complete square. Means we have to add a perfect square number to the left side of that equality, then it becomes complete square. Okay, see here. We have to consider that suitable term means k, means x square minus 5x plus k is equal to 0. That suitable term we have to take k here. Okay, and it means we have to consider square of the first term, that is a. We have to suppose that added number will be k, and we have to suppose that will be x minus a bracket square, middle sign will be minus, and that added term we have to calculate finally. Means we have to write here x minus a bracket square. We have to square the right side. See here, x square minus 5x plus k, this is the left side as like this one, and it becomes square of the first term minus 2 into first term into second term. A into x means ax. 2 is the coefficient of ax. Okay, plus square of the second term. We have to compare these two now. Okay, means minus 2a and minus 5 are same. If we have to compare these two, coefficient of x, therefore we have to take on here minus 2a is equal to minus 5. Both side minus sign is there, we have to neglect that one. Therefore it becomes 2a is equal to 5. We have to find out value of a, therefore we have to take 2 to the right side of that equality, then it goes in the denominator place, then it becomes a is equal to 5 upon 2 is the simplest form of that one. We got here value of a by comparison of these two. Okay, also k means a square by comparing these two. Okay, k means a square, we have to write that one also. K is equal to a square. We have to put value of a, that will be here, means k is equal to 5 upon 2 bracket square. Okay, we have to square 5 upon 2, then it becomes k is equal to 25 upon 4. This is the simplest form. Again we have to take the equation first. Okay, see here, x square minus 5x plus 3 is equal to 0. We have to add this suitable term and also subtract that suitable term, then the equation becomes same. See here how that will be. X square minus 5x plus 25 upon 4, and subtract that one, minus 25 upon 4 is plus 3 is equal to 0. Means this is the original part, and we have to add it, and that will be subtracted. Means totally its value will be 0. Okay, but we have to see now first three terms. This is the complete square term. Okay, means we have to take square root of this one, square root of this one, and sign of the middle term. Therefore it becomes x minus its square root will be 5 upon 2 bracket square, and about this one we have to take minus sign out of the bracket, then it becomes 25 upon 4 plus becomes minus 3 upon 1. We have to write this term as like this one, but in this case denominator is not same, therefore we have to cross here, cross multiplication we have to do here, then it becomes x minus 5 upon 2 bracket square minus in bracket 25 ones are 25, multiplication of these two, minus multiplication of remaining two, minus 4 3s are 12 upon multiplication of denominator, that is 4 1s are 4 is equal to 0. Subtract, and we get here x minus 5 upon 2 bracket square minus 13 upon 2 is equal to 0. Again we have to write this term. We have to take 13 upon 4 to the right side of that equality. Then it becomes plus. See here, x minus 5 upon 2 bracket square is equal to 13 upon 4. Then we have to take square root to the both side. Its square root will be x minus 5 upon 2 and its square root will be root 13 upon 2, because we can't find out square root of 13. Okay. Then it becomes x minus 5 upon 2 is equal to plus root 13 upon 2, and second will be x minus 5 upon 2 is equal to minus root 13 upon 2. If we have to square this term, we get 13 upon 4, and also square of this term, we get also 13 upon 4. Therefore, these two are the roots of that one. Okay, we have to go ahead. Then it becomes, we have to take 5 upon 2 to the right side of that equality. That minus 5 upon 2 is converted into plus 5 upon 2. Therefore, x is equal to 5 upon 2 plus root 13 upon 2. X is equal to 5 upon 2 plus root 13 upon 2, and x is equal to 5 upon 2 minus root 13 upon 2. Because 5 upon 2, its sign will be minus there. See here. We have to take this term to the right side, then its sign will be changes. Its sign will be changes. Okay. Now, denominator will be same. Denominator will be same. Therefore, x is equal to 5 plus root 13 upon 2, and x is equal to 5 minus root 13 upon 2. Okay. Therefore, we can't add or subtract these two terms. Therefore, finally we have to write 5 plus root 13 upon 2 and 5 minus root 13 upon 2 are the roots of given quadratic equation. This is the final answer. Okay. Similarly, we have to see the another type of example. See here, 2y square plus 9y plus 10 is equal to 0. In this case, coefficient of square term is 2. Therefore, first we have to divide 2 to the both side. Suppose here 3, we have to divide 3. Here 4, we have to divide 4. But in this case, in this example, 2 is the coefficient. Therefore, we have to divide 2 to the both side. Divide both side by 2. Yes, see here, 2y square upon 2 plus 9y upon 2 plus 10 upon 2 is equal to 0 upon 2. Here 2 get cancelled. 2 1s are 2 5s are, and here 0. Okay. Then it becomes y square plus 9 upon 2y plus 5 is equal to 0 upon 2 means 0. This is the equation. Okay. Now, LHS means this left side is not a complete square. Therefore, we have to add a suitable term to the left side and then subtract. Then that left side first 3 terms are the complete square. See here, LHS is not a perfect square number. Add a suitable term to the left side. Then it becomes complete square. We have to write this statement in this example. Therefore, y square plus 9 upon 2y. This is not a complete square number. Therefore, we have to take here k. And here plus, therefore y plus a bracket square we have to write here. Suppose here minus, we have to take minus. Here plus, we have to take plus. Okay. We have to write the expansion of this one. Then it becomes y square plus 9 upon 2y plus k is equal to y square plus 2 into first term into second term means 2ay plus square of the second term means a square. See here. These two are the coefficient of y. Means 9 upon 2 is equal to 2a. It becomes 2a is equal to 9 upon 2. We have to multiply here. Then we have to take in the denominator place. Then it becomes a is equal to 9 upon 2 into its denominator 1. We have to take a reciprocal of this one means 1 upon 2. Finally, it becomes 9 upon 4. A is equal to 9 upon 4. Then k means a square. We know that k means a square. Therefore, we have to write k is equal to a square. We have to put this value here. K is equal to 9 upon 4 bracket square, because value of a is 9 upon 4. This is the value for a. Therefore, we have to write here 9 upon 4 and square it. It becomes k is equal to 81 upon 16. Okay. This is the value for k. We have to add this 81 upon 16 to the left side and also subtract it. We have to write that equation first. Y square plus 9 upon 2y plus 5. We have to add 81 upon 4 here and also subtract. Then it becomes y square plus 9 upon 2y plus 81 upon 16 minus 81 upon 16 plus y is equal to 0. Okay. Means we have to add that perfect square number and also subtract. Then the equation becomes same, because these two terms are opposite terms. Okay. Now this is the perfect square. Square root of this one, square root of this one, and middle sign we have to write here. Then it becomes square root of this one is y. Square root of this one is 9 upon 4. 81 upon 16. Its square root will be 9 upon 4. Middle sign will be plus bracket square. We have to take minus sign out of the bracket. Then it becomes 81 upon 16. Plus is converted into minus 5 upon 1 is equal to 0. Here denominator not same. Cross multiplication we have to do there. Then y plus 9 upon 4 bracket square is equal to 81 ones are 81 minus 16 into 5, that is 80. 16 5s are 80, and multiplication of denominator will be 16 ones are 16 is equal to 0. Subtract and write the answer. Y plus 9 upon 4 bracket square is equal to minus 1 upon 16. 1 upon 16 is the answer, is equal to 0. Now we have to take this term to the right side. Then it becomes plus. Okay. So here y plus 9 upon 4 bracket square is equal to 1 upon 16. We have to take square root to the both side. Its square root will be y plus 9 upon 4 and its square root will be 1 upon 4. Plus 1 upon 4 and minus 1 upon 4. They are taken here. Plus 1 upon 4 and minus 1 upon 4. Okay. Left side is same one. Now we have to take 9 upon 4 to the right side. Here also 9 upon 4 to the right side. Then it becomes y is equal to 1 upon 4 plus is converted into minus 9 upon 4, and here y is equal to minus 1 upon 4 plus 9 upon 4 is converted into minus 9 upon 4. Okay. Denominator same. Okay. We have to write that denominator and subtract the numerators. Then it becomes y is equal to 1 minus 9 upon 4 and y is equal to minus 1 minus 9 upon 4. Different signs, sign of larger number and subtract. And here same signs, you write that sign and addition. Then it becomes y is equal to minus 8 upon 4 and y is equal to 10 upon 4. Simplify. 4 ones are 4 twos are 2 twos are 2 fives are. Okay. Then value of y will be minus 2 and y is equal to minus 5 upon 2. Minus 2 and minus 5 upon 2. These are the values of y. Therefore, finally we have to write minus 2 and minus 5 upon 2 are the roots of given quadratic equation. This is the completing square method which is given in the textbook. Okay.